Hello everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम लोग जो स्टार्ट करेंगे वो आर्टिफिशियल इंटेलिजेंस की क्लास स्टार्ट करेंगे, जो कि क्लास नंबर आपका 6 है। ऑलरेडी हम 5 क्लासेस कर चुके हैं, जिसमें हमने यूनिट 1, यूनिट 2 एंड यूनिट 3 हम ऑलरेडी कंप्लीट कर चुके हैं। यूनिट 3 हम आज स्टार्ट करेंगे। यूनिट 1 इंट्रोडक्शन टू आर्टिफिशियल इंटेलिजेंस, and of course that the unit 2 we had covered up here, and that is in the reference towards we had completed to introduction to such as well. And in this class we'll start with unit 3, that is the name of the unit is knowledge representation and reasoning, where we'll discuss this unit 3. And here this is very important unit as well, and this is helpful to you as well. So please, it's a huge request from my side to all of you, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Let's go ahead to discuss in the knowledge representation and reasoning, that we have to start discussing that the first question that has been asked many times, that is of 10 marks, and which is briefly describe the meaning of knowledge representation and knowledge acquisition. What procedure is followed for knowledge acquisition? Explain. That's what we have to explain, that has been asked of 10 marks here. So first we'll discuss the knowledge representation here. Knowledge representation. So in the knowledge representation, if I'm talking about here, and with the same case where we have to discuss about knowledge representation. In the knowledge representation is the study of ways of picturization of knowledge, and how effectively it resembles the representation of knowledge in human brain, where the knowledge representation has two entities. The first entity we have is your facts. In the facts here, that is, it represents that facts are the truth in some relevant world, and where the second we have is your representation. In the terms of the representation here, that is where the fact representation is the presentation of fact in some chosen formation that has comes towards it. And for example, the fact is that like Charlie is a dog, and representation of the fact using the mathematical logic is like dog and Charlie. So let's go ahead with the detail of facts and representation here. The facts we have, that is here in the terms, that is your, that is Charlie is a dog. But for the representation of this we have that we have here is, that is dog Charlie. Okay, so this is how you represent it here. In the same case, the knowledge representation should process following characteristic. The first characteristic it possesses, that is the representation scheme should have a set of well-defined syntax and semantic. The second the characteristic it consists of, that it should have good expressive capacity, and the third is that it must be effective here. In the same case, now we'll talk about in a detail about knowledge acquisition. The knowledge acquisition here. In the term of knowledge acquisition here, with that what we have to discuss in the knowledge acquisition, that knowledge acquisition is the process of acquiring the knowledge from the human expert for an expert system, which must be carefully organized into if then rules or some other form of knowledge, that is representation. And knowledge acquisition is the process of absorbing and storing new information in memory, and the success which is determined by how well the information that can later be retrieved from the memory. memory. The process of storing and retrieving the information depends heavily on the representation and the organization of the information here. In the same case, we'll discuss about the procedure for the knowledge acquisition here. Procedure for knowledge acquisition. So in the knowledge acquisition, if I'm talking about the procedure here, that the first procedure we have is your, that is identification. In the identification, that break the problems into the part. The second we have is your, that is conceptualization, and this that identify the concept here. And the third we have, that is your, the formalization. In the formalization, that represent the knowledge here. And the fourth we have is implementation. In the implementation, that is your programming. And the fifth and the last is your testing, where it consists of the validate of knowledge here. So here that we'll discussed in a detail, and with the same reference towards it, that the reformation, the concept, the structure, refinements, formulating to the embedded knowledge, the implementation and the conceptualization, that we'll discuss with the stages of the knowledge acquisition that we have to discuss here. So let's go ahead. So here this is the representation, and where this is identification, this is formalization, and this is testing. In between that, the first we have that identification is to identify problem, characteristics, and where that is to find concept, to represent knowledge, here to design a structure, to organize knowledge, and here to formulate rules to embody knowledge, and here to validate rules that organize knowledge. With the identification to find it out, these were the requirements. With the same finding to the design, that is the concepts. The next we have here is your structure, and then it's your rules. With the same concept, with the identification from the testing, it will goes to the identification, and that is your reformulation. Then it will goes to the testing goes to this the fine concept here, and that then the redesigns goes this is the redesign concept that goes to the design structures to organize knowledge, that is redesign. And here for that, this is your refinements. Okay, these were the these two comes under the conceptualization, and this is what it is and comes under the implementation. And this is all we can't tell us that is comes under the stages of knowledge acquisition. Now we'll discuss about describe the technique of knowledge representation. So that what we have to discuss here, that is technique of knowledge representation. That is comes under, that has been divided into the four here, and that is as follows. We are in the terms of the technique of the knowledge representation. The first we have is your logical representation. In logical representation, the logical representation is a language with some concrete rules which deals with the proposition and has no ambiguity in representation. Well, logical representation means drawing a conclusion based on the various conditions, and it consists of precisely defined syntax and semantics which supports the sound inferences, and each sentence that can be translated into the logics using the syntax and semantics as well. Where the second we have here is your, that is semantics network representation. Semantic network representation. In the semantic network representation here, that the semantic networks are alternative of predicate logic for the knowledge representation, and it is the semantic network we can represent our knowledge in the form of the graphical network as well. And this network consists of the nodes representing objects in arc which describe the relationship between the object as well. With the same semantics, semantic networks can categorize the object in a different forms, and that can also link those object as well. The third we have is your frame representation. In the frame representation, a frame is a record-like structure which consists of a collection of attribute and its value to describe an entity in the world. And frames are the AI, that is artificial intelligent data structures, which divides knowledge into the substructures by representing the stereotype situation, and it consists of a collection of slots and slot values. These slots may be or any type of size, and slots have names and values which are called facets as well. The fourth we have is your production rules. And the productions rule here, that is a production rule system consists of the condition action pairs, and which means if condition then action. So in production rule agent that checks the condition, and if the condition exists, then production rule and corresponding action is carried out, and the condition part of the rule determines which rule may be applied to a problem, and the action part carries out the associated problems and solving the steps as well. And this complete process is called recognize act cycle. So here we have here, that is your technique of knowledge knowledge representation, that is logical representation, semantic network representation, frame representation, and the production rule as well. Let's go ahead with another one that what we have to discuss about it, that is the what are the desirable properties of a good knowledge representation scheme. Properties of good knowledge representation schemes. This has also been asked 10 marks here. The properties of desirable properties of good good knowledge representation schemes that we have to discuss here. A good system for the representation of knowledge in a particular domain that should possess the following four property, where the four property we have, the first property we have is your representational adequacy. Representational adequacy. In the representational adequacy, the ability to represent all the kinds of knowledge that are needed in that domain. The second we have as your inferential adequacy. In the inferential adequacy, the ability to manipulate the representational structures in such a way as to derive new structure corresponding to the new knowledge inferred from old. The third we have, that is inferential efficiency. In the inferential efficiency here, the ability to incorporate into the knowledge structure the additional information that can use to focus the attention of the inference mechanism in the most promising direction as well. The fourth we have is your, that is acquisitional efficiency. In the acquisitional efficiency here, that the ability to acquire new information easily, and the simplest case involves direct insertions by a person of a new knowledge into the database, and ideally the program itself would be able to control the knowledge acquisition here. Let's go ahead with a further one, and that is what we have to discuss about it in the terms of the knowledge representation here, that is your propositional logic, and describe the types of the propositional logic as well. Propositional logic. In the propositional logic here that we have to discuss is your propositional logic, that is PL is the simplest form of logic, and where that all the statements are made in the propositional, and a proposition is a declarative statement which is either true or false. It is a technique of knowledge representation in the logical and a mathematical form. The propositional logic is also called a Boolean logic as it works as 0 or 1. 0 and 1. With the same case that in a propositional logic we use symbolic variable to represent the logic, and the propositional can be either true or false, but it cannot be both. The two types of propositional logic we have, types of propositional logic. The first we have is here, that is atomic proposition. In the atomic propositional here, in the terms of atomic propositional, what we have to discuss here in the atomic propositional, that is atomic propositional are the simplest proposition, and it consists of a single proposition system. There are the sentences which must be either true or false. For example, like 2 plus 2 is 4, so it is an atomic propositional as it's a fact, it's a true fact as well. And the sun is cold is also a proposition as it false fact. So okay, so these were the thing that comes under the atomic propositional here. Now we'll talk about the second one that we have is your, that is your compound propositional. In the compound propositional here, that the compound propositional are the constructed by the combining simpler or atomic proposition using the parenthesis and the logarithm conditions. For example, that it is raining today and street is wet. And the another is that Ankit is a doctor and his clinic is in Mumbai. So this is what comes under the compound proposition here. Let's go ahead with the another one there where we have to discuss about logic connectives. That is your logical connectives here. Logical connectives. So in the terms of the logical connectives here, the logical connectives are used to connect two simpler proposition or representing a sentence logically. We can create compound propositional with the help of the logical connectives, and there are mainly 5 connectives which are given as follows. The first we have is your, that is negation. In the negation, a sentence such as your P is called negations of P, that a literal that can be either positive, a literal, or a negative literal as well. The second we have is your, that is conjunction. In the conjunction here, that a sentence which has this connectives such as P connect with Q, that is, and it's called a conjunction. And we are in the terms the another we have is your disjunctions here. In the disjunctions here, that a sentence which has this connective like P, this connective is called disjunction, where P and Q are the proposition here. The fourth we have is the amplification. In the amplification here, that is comes under that a sentence such that P tends to Q, that is called amplification. And amplification are also known as if then rules, and it can represented by if it is raining then the street is wet, like P is equals to, that is it is raining, and Q is equals to, that is the street is wet, so it is represented like P and then Q. The next we have the fifth one, that is your, that is biconditional. In the biconditional, a sentence such that representing a biconditional, example, if I am breathing then I am alive. So P is I am breathing and Q is I am alive, so it can be represented in the form of this. So this is what comes under the logical connectives and the types of logical connectives that we have to discuss here. Let's go ahead to discuss about the propositional logic here and the various interfaces rules with the help of an example. That is, we have the modulus ponens and modulus tollens, so that we'll discuss here as well. And let's go ahead. We will be helped to discuss about it. That is, yeah, that is comes under your, that is the various inferences. That is various inferences rules. So here that various inferences rule, the first we have here, that is your modus ponens. Here we'll discuss about the modus ponens here, and that modus ponens, that is the modus ponens rule states that if P and that is your P tends to Q is true, then we have an infer that the Q will be true here. And for that we'll take an example where the two statements and one conclusion, and hence we'll do that by proof by the truth table here. So the question we have here is, that is that the statement we have here, that is statement 1 is that if I am sleepy then I go to bed. That is P tends to Q. Where the statement second we have I am sleepy. This is P. Where conclusions we have that is I go to bed. Okay, so this is Q. With the same, hence we can say that P tends to Q here, and that is true, and P is true, then Q will be true, and for that we will make a truth table here. Proof by truth table that we have that it is P, Q, and P tends to Q. So for if P equals to 0, then Q is also 0, and P tends to Q is also 0. If P is 0 and Q is 1, then it is 1. And if P is 1 and Q is 0, then it is 0. And if P is 1 and Q is 1, then of course P tends to Q is 1. Okay. So this is a truth table we have to draw with reference towards this example. Let's go ahead with the another one, that the second one is, that is your modus tollens. In the modus tollens here, that the modus tollens rules that states that if P tends to Q is true, then Q is true, then P will be true here. So for that we will go ahead with the discussion, and we will do the same for the truth table as well. And the statement we have here, that's the same statement will take, if I am sleepy, then I go to bed. This is, and then I do not go to bed, and which refers to the statement. So let's go ahead with the three statements here that we have. Statement 1, statement 2, and statement 3. So let's go ahead with the statements here. That the first statement we have, if I am sleepy, then I go to bed. This is P tends to Q. And here I do not go to the bed. Okay, this was somewhat Q, and which infers that I am not sleepy. That is P. Let's go ahead with the proof by truth table. So proof by the truth table, that what we have to discuss here, that is your P, Q, P, Q, and P tends to Q. So here for that, if P is 0, Q is 0, and this is 1, 1, then it will be 1. Okay. And if P is 0, Q is 1, 1, then 0, we have 1. Then again we have 1, then 0, 0, 1, then we'll have 0. Then we have 1 1, either it is 0, then we have 1, so we'll go ahead with 1. So this is how you can make a truth table for this particular 3 statements which it have. Let's go ahead with another one, that is your hypothetical syllogism. In this, that the hypothetical that is syllogism rule that states that if P tends to R, that is true, where P tends to Q is true and Q tends to R is also true here. So let's go ahead with the statement, and where we have to make a truth table as well. So let's go ahead with the statements here. Statement 1, statement 2, statement 3. And even though we statement 3, we have a conclusions here. Only 2 statements are there. So let's go ahead. If you have my home key, then you can unlock my home. Okay, what it stands for, if you have my home key, so then you can unlock my home. This tells P tends to Q. The second statement we have, if you can unlock my home, then you can take my money. It stands for Q tends to R. The conclusion is, if you have my home key, then you can take my money. This states that P tends to R. Okay, so with the same references, we'll go ahead with the that is your the truth table, and then we'll go ahead with another one, that is your disjunctive syllogism here. Now we'll make a truth table. Proof by truth table. Where we have here is your P, Q, R, P tends to Q, Q tends to R, and of course that is P tends to R. So we'll go ahead. So here we will be having, when it is 0, then 0 0, if all the 3 0, and here all the 2 was 1, so all the 3 will be 1 here. If here that is 0 0 1, then of course the 1 1 and 1 for this. For the another one, another case, we have here 0 1 0, then 1 0 and 1. For the another one we have here is your, that is 0 1 1, and then 1 1 1. This is. Then we have the another one, and that is your 1 0 0, then 0, that is gives you 1, and then we have 1 0, then 1 0, we will get 1 1, and then again we have 1 1 0, then 1 0 0. Then again we have here 1 1 1 1 1 1. This is for all. These were the possible values which we are drawing with the help of a truth table. So here we'll go ahead with the fourth one, that is your another one, that is your fourth one, that is your disjunctive syllogism. In the disjunctive syllogism here, that the disjunctive syllogism rule that if P Q is true, then P is true and Q will be true as well. So then after that, the statement we have here, statement 1, statement 2, and even the conclusions. So here we'll go ahead. Today is Sunday or Monday. That stands for PQ. Okay. Next this either Monday or Sunday now. So here, today is not Sunday, that is, and today is Monday. So now we'll go ahead with the truth table here. With the same we have P, Q, P and P. With the same here, that for the truth table we have 0 0 1, then again we have 0 0 1 1 1, then 1 0 0 1, then 1 1 0 1. So this is reference towards disjunctive syllogism. Let's go ahead with the another one, that is your addition. Addition. In addition, the addition rule states that if P is true and then P and Q is also true. So examples we have here, the statement 1, statement 2 and conclusion. So what we have here is the statement 1 is I have a vanilla ice cream. This is P. Then I have chocolate ice cream. This is Q. And I have vanilla or chocolate ice cream. That is P, Q. So the proof of truth table that we have is just P, Q and P, Q. In the same case, in the addition case, if it is 0 0, then it is 0. If it is 1 1, then it is 1. and if it is 0 1, then of course it is 1, and if it is 1 1, then it will be 1. Okay, so the another we have is your sixth one, that is your simplification. Simplification. In the terms of simplification, the simplification rule state that just Q, then Q or P will be true. So let's go ahead with the proof by truth table. So here we have PQ and PQ. In the same case for the simplification, that is 0 0, then it will be 0. If it is 1 0, then it will be 0. And if it is 0, it is 1, then it will be 0. And if it is 1, then 1, then again we have 1 here. So this is for the simplification. Let's go ahead with the another one, that what we have to discuss here, and in the same case what you have to go through with as well, that the another we have is your resolution. The another we have here is your seventh one, that is resolution. In the resolution rule states that PQ and that is P tends Q here, P R is true here, and that is then of course that Q and R that is will be also true here. With the same case, let's go ahead with the detail, and let's prove with the truth table. Proof by truth table. So here we have P naught, Q R, PQ not P Q, that is your R, and then Q and B R. So let's go ahead with this. So here we'll have this, and for this is 0 1 0, this is 0 0 0 and 0. For the another one, that is your 0 1 0 1 0 0 and 1. Then for the another one we have here is that is 0 1 1 0 1 1 and then 1. So for that it will be the another one we have is your 0, that is your 1 1 1, and then again we have 1 1 and 1. Then for another one we have 1 0 0 0, then 1, this is 0 and then 0. Then for another one, that is 1 0 0 1 1 0 1, and then we have 1 0 here, that is your 1 0 1 1 0, and then we have 1. The another one we have 1 0 1 1 1 0 1. So this is a truth table for the resolution here. So how you will make the truth table for each and every here, every one here. This like now we'll just go on discussing that, explain the conversion procedure of a given formula into that is your in the normal form, and that has been asked of 10 marks, so that is very important. So let's go ahead. Conversion procedure of given formula into normal form. For this here, that is the steps to use to convert for given formula into its normal form are as to be as follows. There were the three steps. The first step is to eliminate the amplification and biconditionals. For this, use the law, and what we have step 1, that is it tends to be there this is a bidirectional which is equals to a tends to be. We'll open that. Then in the second step we have is your, that is to reduce the not symbol and the formula, that is we are using here step 2, and that the formula as we are using a equals to a, and then apply the De Morgan's theorem to bring negations negations before the atoms here. So we'll go ahead. That is comes under now. In the third step, what we will be doing is that use the distributive law to obtain the normal form here. That we have in this third step that we have to use, as I told you, about the distributive law to obtain the normal form. So that is we have that is in the same case. This has been asked of 10 marks, so you have to write it down, copy it down if you had not copied it. Let's go ahead with the another one, that is the proof the following sentences is valid. That if the price falls, then the sell increases, and if the sell increases, then John makes the whole money, but John does not make the whole money, therefore the price do not fall. So with that sentences, this has been asked of 10 marks, and in the same references we have to do it, and that has been asked in 17, 18 as well. So let's go ahead to do that. That is your the question. I will be writing it. If prices fall, then cell increases, then John makes the whole money, but John does not make the whole money, therefore prices do not fall. This has been asked of 10 marks. Okay, so let's go ahead with this, and we have to prove it as well. And if the price falls, then the sell increases, and the logical form of the sentence is if P then Q, and if sales increases, then John makes the whole money, and the logical form of the sentences is if Q then R. With the same references, if we have to check the validity of the sentences, that John does not make the whole money, therefore the price do not fall, and where that stands for, and hence from we will going ahead to solve it. P tends to Q. For that, that is, if the price falls, then the sell increases, and the logical form of the sentences is that P tends to Q, that price falls, sell increases. And where Q tends to R, that is sell increases, John makes whole money, and we'll get P tends to R, cancel it out Q. So here the price falls, John makes whole money. And from the transportation rule, if I'm going to do transpositional rule, that is P tends to R, and info or tends to A, here we conclude that John does not make the whole money, therefore the price do not fall, and hence the given argument is valid. So this is valid here, which has been given. This has been 10 marks. Let's go ahead with the another one, that we have to describe that the first order logic in artificial intelligence. First order logic in artificial intelligence. So here in the first order of artificial intelligence, that what we had to discuss, that is very important, because the first order logic is also known as the predicate logic, or the first order predicate logic. Here the first order logic is a powerful language that develops information about the object in a more easy way, and can also express the relationship between those objects. First order logic is an extension to the propositional logic, and first order logic is sufficiently expressive to represent the natural language statement in a concise way. First order logic, that is like natural language, does not only assume that the world contains the fact like propositional logic, but also assumes object relations functions as well. As a natural language, first order logic also have two main parts, syntax and semantics, here in the case of the first order logic in artificial intelligence. Let's go ahead with another one, that what we have to talk about in the detail. And in the same case, where we'll go ahead and with the theory, if I'm going out, because there are many that is your numerical part which we have to discuss here. So we will be discussing about the forward chaining and the backward chaining here. That has been presented here. That is your forward chaining and backward chaining. So here forward chaining and a backward chaining, if I'm talking about. So in the forward chaining, this two has been asked of 16, 17 of 5 marks, wherein the forward chaining is a method of reasoning when using inferences used in the artificial intelligence. And forward chaining start with the available data and uses the inferences rule to extract more data from an end user, and until an optimal goal is reached. An interface engine using a forward chaining such as that the inferences rule until it's find any one where the if clause is known to be true, and when found it can conclude or infer, then yes, of course, then clause, and that is resulting in the addition of the new information to its data set as well. The inferences engines will often cycles through the process until an optimal goal is reached. For example, suppose that the goal is to be conclude that the color of my pet Bruno, given that he croaks and eats flies, and then the rule base contained that the following two rules: that if x croaks and eats flies, then x is a frog, and if x is a frog, then x is red. So in that same case, that has been happened. Let's go ahead with the backward chaining here. In the backward chaining, that the backward chaining starts with a list of the goals or the hypothesis, and works backward to see, and if there is a data available that we will be support any of these goals. Any inferences engines use backward chaining would search the inferences rule until it finds which and then clause matches to the desired goal as well. In the same case, if the clauses of that inferences rule is not known to be true, then it is added to the list of the goals. For example, suppose that the goal is to be conclude the color of my pet Bruno, then given that the crocs and eat flies, and that the rules contain the following two rules. With the same case, if x crocs and eat flies, then x is a frog, and if x is a frog, then x is a red. That is comes under the backward chaining. Now we'll talk about the properties. So in the properties of forward chaining here, that they can ask you write down the properties of forward chaining and backward chaining. So we'll discuss both the properties for the forward chaining and as well as the backward chaining as well. So in the properties, the first we'll talk about the forward chaining, which is if it is down up that is down up approach, as it moves from the bottom to up here. And with the same case, if I'm talking about with a chaining that we have in the reference towards a forward, that is it is a downward approach, and it's a move from bottom to up. It is a process of making a conclusion that is based on the known fact or the data by starting from the initial state and reaches the goal state. The forward chaining the approach is also called as data driven, as we reach to the goal using the available data. And forward chaining approach is commonly used in the expert system such as the business and the production rule system as well. While in the same case, we'll talk about the that is the properties of backward chaining here. In that backward chaining, it is known as the top down approach, where the backward chaining is based on the Modus Ponens inferences rule. And in the backward chaining, the goal is broken into sub goals, and the sub goals to prove that fact true here. It is called that a goal. Here we'll go with the third one, that what we have is your properties. And in the backward chaining, the goal is broken into the sub goals, and the sub goals to prove that the fact true, and it is called a goal driven approach, and as it's a list of goals decide which rules are selected and used. The backward chaining algorithm is used in the game theory and automated theorem, that is proving tools, and inferences engines, proof assistants, and various all that AI application, that is your artificial intelligence application as well. The backward chaining method mostly used in the depth for such strategies for proof as well. Let's go ahead with a very important question, that is the difference between. In the difference between forward chaining and backward chaining, that is very important, that has been asked many times, and that is of 10 marks as well, that the differentiate between the forward and a backward chaining of inferences with the help of an example. So the forward chaining will discuss more than 5, of course, the differences between the both. In the forward chaining, that the forward chaining is a data driven method, and backward chaining is a goal driven method. In forward chaining, it uses planning, monitoring, and controlling method. In a backward chaining, it uses the diagnosis method. In a forward chaining, it uses the bottom-up processing. Backward chaining, it uses a top-down processing. In a forward chaining finds a possibly conclusion support by the given facts, and for the backward chaining, that the backward chaining finds the fact that support a given hypothesis. In a forward chaining, the forward chaining is similar to the breadth first search. For the backward chaining is similar to the depth first search. For the forward chaining here, that is your, for example, that is clips, and for the backward chaining, for example, the prologue. These were the examples and the differences between the forward chaining as well as the backward chaining that we had discussed about it, and many more things we have to discuss about it in the reference towards each and every topic that we had discussed here. But the rest of the things we will discuss in the next coming class. So today we will end up here, and first of all, it's a huge request from my side to all of you. Please go through with the subscribe button and please like, share and subscribe to my channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the term of the artificial intelligence, what we had covered up in the unit 1, that is your introduction to artificial intelligence, foundation and history of artificial intelligence, application of artificial intelligence, intelligent agents, structures of intelligent agent, computer vision, natural language processing. And in the introduction unit 2, we had covered up that is introduction to search, searching for the solution, uninformed search strategies, informed search strategies, local search algorithm and optimistic problem, adversarial search for games, alpha beta pruning. Unit 3rd that we had started, and that is the knowledge representation and reasoning, where we have to discuss about knowledge representation and reasoning, propositional logic, theory of the first order logic, inferences in the first order logic, forward and backward chaining that we had completed here, and the resolution and the probabilistic reasoning, utility theory, hidden Markov model, that is very important, that is HHM, and Bayesian network that we have to discuss here. Then other than after that, we'll have to start with unit 4, that is so machine learning, where we have to discuss about it, that is machine learning. In this, that is supervised and unsupervised learning, decision tree, statistical learning models, learning with complete data, Naive Bayes models, learning with hidden data, EM algorithm, and reinforcement learning as well. In unit 5, that is your pattern recognition. We have the pattern recognition, introduction, design principles of pattern recognition system, statistical pattern recognition, parameters estimations method, principles component analysis, that is your PCA, and the linear discrimination analysis, that is LDA, the classification technique, nearest neighbor, that is NN rule, bias classifier, support vector machine, SVM, and k-means clustering that we had completed. So we have to complete it in this coming classes, and please go through with the subscribe button, and please like, share and subscribe to our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And thanks to all those subscribers, those who had subscribed to our channel, please, thanks you, and thanks for supporting us. Please support us as you had supported before, and it's a huge request from my side to all the viewers. Please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.